Coffee beans are not beans at all, they are seeds, protected inside a fruit known as the coffee cherry.
Harvesting is not simply about speed, it's about selection. Ripe cherries are chosen, while underripe and inside each cherry are usually two seeds, what we recognize as coffee beans. At this stage, these seeds contain.
Before beans ever reach a factory, moisture control begins. Drying stabilizes the seeds, preventing fermentation from going too far.
Once dried, coffee beans are prepared for transport as green coffee. At this stage,
Only after passing these early controls do coffee beans begin their journey to industrial roasting facilities.
Before coffee beans ever reach a roasting factory, they must be separated from the fruit that surrounds them. This initial process.
Pulping machines use calibrated pressure to remove the outer skin and flesh without crushing the seed inside.
The preparation. After pulping, beans still carry a sticky layer called mucilage.
Fermentation is a controlled biochemical reaction. Enzymes convert complex sugars into simpler compounds, while acidity levels rise slowly.
Washing channels serve two purposes. First, they remove remaining fermentation residue. Second, they act as a density filter.
Drying stabilizes the bean for storage and transport. Industrial dryers reduce moisture to precise levels.
Moisture is measured continuously. Even a 1% deviation can cause uneven roasting or internal cracking. Once dried and stabilized, coffee officially becomes green coffee, chemically dormant, structurally intact, and before roasting can begin, every batch of green coffee must be inspected. At this stage, factories are not
Size grading is the first mechanical filter. Beans are separated by diameter, using burning screws.
Density sorting relies on physics rather than judgment. Fully developed beans are heavier and more stable.
Optical sorters use high-speed cameras and color analysis to identify defects invisible to the human eye. Discoloration can indicate. These systems operate in milliseconds. Decisions are made faster than human reaction time, allowing thousands of beans per
Tartlet. Despite automation, human inspection remains essential. Random samples are examined for shape, texture, and surface.
Moisture and density data are logged for every batch. These values determine roasting profiles later, influencing airflow.
Only after passing all inspections do beans move forward. At this point, variability has been minimized.
Roasting is the moment coffee truly becomes coffee. Until now, the beans have been chemically dormant.
Industrial roasters begin by loading precisely weighed batches. Batch size matters because it determines how heat moves through the drum.
Inside the drum, beans are constantly in motion. This rotation ensures heat is transferred evenly through condensate.
As temperature rises, complex chemistry begins. The Maillard reaction transforms sugars and amino acids into As temperature rises, complex chemistry begins. The Maillard reaction transforms sugars and amino acids into hundreds.
As temperature rises, complex chemistry begins. The Maillard reaction transforms sugars and amino acids into hundreds.
As temperature rises, complex chemistry begins. The Maillard reaction transforms sugars and amino acids into hundreds of aromatic compounds.
When the target profile is reached, beans are released immediately. From this moment onward,
Rapid cooling works by convection. Cooler air absorbs residual heat from the bean's core, stopping Maillard reactions and
cooling trays use forced airflow drawn downward through perforated steel. As beans are constantly stirred, heat is.
Sensors confirm when beans have reached a stable temperature. Cooling too slowly allows flavor drift. Cooling too
Freshly roasted coffee is chemically active. Exposure to oxygen, heat, or light at this stage can.
only after cooling and initial degassing are beans ready to move forward, either toward grinding, blending, or packaging. Factories allow controlled resting before packaging or grinding. This stabilizes pressure inside the bean. Grinding is not simply breaking coffee into smaller pieces. It is a precision engineering step that determines how water will interact with coffee during brewing. Industrial coffee grinders rely on burr systems rather than blades. Burrs fracture beans gradually, producing uniform particles.
Particle size determines extraction speed. Fine particles release compounds quickly, while larger particles extract more.
Grinding generates friction, and friction creates heat. Excess heat can volatilize aromatic oils before brewing.
Before grinding begins, beans are metered into the system at a controlled rate. Feed consistency prevents sudden low. Ground coffee oxidizes rapidly. Factories minimize oxygen exposure by shortening holding time and sealing systems.
At this point, coffee is fully prepared for final formulation, whether blended for flavor consistency or...
Each component of a blend is stored separately. Different origins and roast levels contribute specific characteristics.
Blending is where coffee becomes predictable. While single origin coffees highlight individuality,
blending begins with exact measurement. Automated dosing systems use load cells to dispense coffee within gram levels.
Ribbon blenders mix coffee gently to avoid particle damage. Internal paddles circulate material in opposing directions.
Uniformity is verified by sampling from multiple locations within the batch. Variations in particle distribution can...
Despite automation, human sensory analysis remains critical. Trained panels evaluate aroma, acidity, mouthfeel, and aftertaste.
Once approved, blend recipes are digitally locked. Every future batch references this data, turning flavor into a rotation.
With blending complete, coffee is now finalized in flavor and composition. From here, the focus shifts. Once coffee is blended and stabilized, packaging becomes the final protective barrier. From this moment forward,
fresh coffee continues to release carbon dioxide. One-way valves allow...
Oxygen is coffee's primary enemy. Nitrogen flushing displaces oxygen inside the package, slowing oxidation, and heat sealing locks the environment inside each package. Temperature and pressure must be carefully calibrated to avoid micro-leaks that could compromise shelf life.
Date coding links each package to its production data. This traceability allows factories to monitor shelf life, recall...
Every sealed package is inspected. Optical cameras detect misalignments, while pressure tests verify seal strength.
with packaging complete, coffee is now protected from its environment. Flavor, aroma, and freshness have been sealed.
Before coffee leaves the factory, it enters its final checkpoint. Quality assurance exists to verify.
Samples are drawn from every production batch. These samples represent thousands of units, allowing factories to validate quality without interrupting high-speed production.
Oxygen and carbon dioxide levels are measured to confirm packaging integrity. Excess oxygen accelerates oxidation.
Shelf life testing simulates months of storage in a compressed time frame. By exposing coffee to controlled heat and humidity,
only after all data aligns with specification is a batch approved. Quality assurance transforms subjective flavor into measurable, repeatable standards.
Quality control extends beyond aroma. Brew tests confirm that grind size, extraction rate, and flavor balance. Trained sensory panels provide the final confirmation. They detect deviations that instruments cannot, ensuring the coffee tastes exactly as designed.
With testing complete, coffee is cleared for release. Freshness has been verified, stability confirmed, and
once approved, coffee enters the final engineered environment, the warehouse. Here, storage...
Automated palletizers ensure load stability. Even weight distribution prevents package damage and microseal failures during long-distance transport.
Warehouse management systems control temperature, humidity, and stock rotation. These parameters slow chemical degradation and ensure older batches ship first.
Orders are assembled using automated routing systems. This minimizes handling time, reducing exposure to heat and oxygen before shipment.
From here, coffee enters global distribution networks, traveling by road, rail, sea, and air.
Loading docks act as the final interface between factory control and the outside world. Timing here matters.
Whether destined for cafés, retailers, or homes, the final quality experienced by the consumer depends on every controlled step that came before.
From a seed inside a cherry to a precisely engineered product, coffee is the result of agriculture,